Even worse, flares are often accompanied by coronal mass ejection, CMEs. While the flare arrives immediately, the CME, moving slower, slams into Earth hours or days later, like a second wave, triggering geomagnetic storms that can disable power grids and satellites. Solar physicists constantly monitor the sun's magnetic fields, searching for signs of instability. The presence of large, complex sunspots, cooler, magnetically active regions on the solar surface, often precedes an X-class flare. The more twisted and chaotic the magnetic loops, the higher the chance of a major release. At Infinity Beyond, we examine how space weather forecasters are racing to improve flare prediction. Satellites like NASA's Solar Dynamics Observatory, SDO, and SOHO, Solar and Heliospheric Observatory, provide high-resolution imagery and magnetometric data, helping us spot trouble before it strikes. But even with this technology, we still lack accurate short-term forecasts. So far, the only truly reliable method of protection is preparedness. Hardened satellite systems, resilient power grids, and public awareness are crucial. Because once an X-class flare is detected, it's already here. In our next segment, we'll look at how solar flares have impacted modern transportation, including shocking incidents where passenger planes and even life-saving medical devices were disrupted mid-flight. Because the sun doesn't just threaten space, it's already knocking on our airplane doors. In 2016, cybersecurity researcher Marie Moe boarded a flight, unaware that her own heartbeat was about to reveal the invisible reach of the sun. Mid-flight, she began to feel something strange, a rapid, involuntary twitching in her chest. It was her pacemaker. Designed to regulate her heart rhythm, it suddenly switched to backup mode. Upon landing, a diagnostics check revealed that one of the device's memory bits had flipped, altered without warning, likely by an external energy burst. This phenomenon is known in computing as a single-event upset, SEU, or more colloquially, a bit flip. It occurs when high-energy particles, often from cosmic rays or solar flares, strike microchips, altering stored binary values. In this case, it changed a 0 to a 1, causing the pacemaker to reset. Though impossible to definitively trace to a specific solar event, Moe's experience isn't isolated. At Infinity Beyond, we've investigated multiple such incidents that show how deeply solar activity can infiltrate modern life support systems. In 2008, a Qantas Airways flight over Western Australia suddenly plunged hundreds of feet, twice, injuring passengers and terrifying crew. The culprit? A software glitch in the aircraft's inertial reference system, likely triggered by a similar radiation-induced memory error. Both cases point to a sobering truth. Solar flares can affect us even inside airplanes at cruising altitude. And the higher we fly, the less protection Earth's atmosphere provides against incoming radiation. Modern jetliners often cruise at 35,000 feet, well within reach of high-energy particles from strong solar events. Radiation exposure at these altitudes is still relatively low, but during intense solar storms, especially X-class flares, the dose can rise significantly. Airline crews, pregnant women, and frequent flyers face greater risks. And that's why some airlines now reroute transpolar flights during major solar activity to minimize exposure. But the impact isn't limited to aviation. Hospitals, military systems, and data centers all rely on vulnerable electronics. Even self-driving cars, drones, and smart home devices contain microchips susceptible to SEUs. In an increasingly digital world, these silent attacks from space are becoming more than rare anomalies. They're emerging as systemic risks. At Infinity Beyond, we believe that public awareness is just as important as satellite monitoring. While large-scale infrastructure failures are dramatic, it's the smaller, personal-level vulnerabilities that go unnoticed until they strike. Imagine the scenario. a patient undergoing surgery, a pilot flying through polar skies, a drone delivering emergency medicine, a solar flare surges, and in an instant, bits flip. This isn't science fiction. It's already happened. As our society integrates AI, autonomous systems, and real-time decision-making electronics, the consequences of cosmic interference are magnified. Without proper radiation shielding, error correction systems, and resilient chip designs, we are building a fragile world under an unpredictable sky. In our next segment, we'll journey back to one of the most mysterious episodes in modern warfare: the unexplained detonation of underwater mines during the Vietnam War, finally linked to a solar storm after decades of confusion. Because the sun doesn't choose its targets, it strikes everything, from satellites to your heartbeat. During the Vietnam War, a baffling incident left military experts scratching their heads for decades. On August 4, 1972, a squadron from the U.S. Task Force 77 was flying routine missions over Haiphong Harbor when, without any enemy activity nearby, 20 to 30 underwater explosions erupted almost simultaneously. These weren't bombs dropped from planes. These were U.S.-planted naval mines, part of Operation Pocket Money, a campaign to blockade North Vietnam by sea. What puzzled the military was that no ships had triggered these mines. They had been carefully designed to detonate only when a magnetic field disturbance, such as that caused by a passing vessel, was detected. So how had they all exploded at once, under clear skies and calm waters? For over 40 years, the cause remained a mystery. That is, until a recent study, accepted by the journal Space Weather, uncovered a startling explanation. The culprit was the sun. At Infinity Beyond, we uncover how this single event reshaped our understanding of space warfare. In the days leading up to the incident, a massive sunspot region, catalogued as MR11976, had become highly active. On August 2nd and the 3rd, it unleashed a series of brilliant solar flares and coronal mass ejections, CMEs, one of which was Earth-directed. This solar storm was powerful enough to disrupt the planet's magnetic field, including the waters of Haiphong Harbor. The resulting geomagnetic disturbance may have been strong enough to trigger the magnetic sensors inside the mines, tricking them into thinking a ship was passing overhead. Boom! The mines detonated, simultaneously, automatically, and inexplicably, until now. This moment marks one of the first known instances in which solar activity directly affected military hardware, possibly altering the outcome of a tactical mission. And if it happened then, it can happen again. Modern militaries around the world rely heavily on magnetically triggered weaponry, communication satellites, GPS-guided munitions, and real-time battlefield data systems. All of these are susceptible to space weather events. Imagine a missile system being blinded, a drone fleet going offline, a stealth submarine losing communication. When space weather intervenes, strategic advantage becomes chaos. At Infinity Beyond, we urge defense sectors worldwide to recognize that solar storms are not just scientific curiosities, they're national security threats. While traditional military training prepares for terrestrial threats, space weather remains a blind spot in many defense protocols. Today, with the increasing use of AI-driven decision systems, the threat compounds. A well-timed solar flare could corrupt data mid-transfer, flip command codes, or disable surveillance satellites, all without a single human error or enemy missile. And yet, despite the risk, global militaries are only beginning to incorporate space weather forecasts into strategic planning. NASA, NOAA, and other agencies now provide real-time alerts, but the reaction time is often limited, especially for systems deployed in remote or space-based theaters. In our next segment, we'll shift from war to communication, how telegraph lines in 1859 caught fire, and how satellites today face similar dangers from the same cosmic source. Because the battlefield is no longer just land, sea, and sky, it now includes the space between stars.